chemistry, we have a lot of relationships between quantities, and the best way to imagine them is graphically. In one of the other videos, we talked about the equation for concentration. Concentration is equal to amount N over V. Now, we would say that concentration is directly proportional to N, the number of particles, number of solute particles in the solution. And here's a graphical relationship which is direct proportional linear relationship between C and N, for example. This is the y equals mx plus c type graph. Okay? As you increase y, you increase x. As you increase concentration, you increase N in a linear relationship. Now, you can also get a negative line or a slope, negative slope, where m is a negative number. That's also a linear relationship. So you'll see these graphs very often. Now, the relationship between concentration and volume, though, is an inverse relationship. If you increase the volume of a solution, keeping m constant, the concentration decreases. And so this is the y equals 1 over x relationship. It's an inverse relationship. So these are graphs that you really need to be familiar with, and whenever you see that equation, imagine the graph. Two other graphical relationships that you'll need to be very familiar with are the exponential relationship, which is when you're looking at the concentration of something in a reaction and the concentration is decreasing with time. Here's the formula that you use to calculate the concentration of something at any particular time. You'll notice it's an exponential decay, it's not a linear relationship. And of course, logarithms. The logarithmic relationship goes like you can see here, and a good example of a logarithmic relationship is the one between pH and the concentration of hydronium ion. So the key thing to remember here is that whenever you look at an equation in chemistry, try and remember what the graphical relationship looks like.